Hey guys, this is Rohan, and today we are going to talk about quantum entanglement. And quantum entanglement is such a fascinating concept that it will literally blow your mind. But before we find out about that, let us find out about what is quantum. Whenever we are thinking about quantum means very, very small. To think about protons, neutrons, or maybe very subatomic particles floating around. So we are talking about that such particles. And entanglement is a very fascinating thing. Entanglement means, let us imagine two particles A and B. They both are entangled here physically, which means that if something has happened to A, we can predict or calculate what happens to B. So this is called entanglement. So for quantum entanglement, we knew that two protons might be entangled. So if we find out the position or some answer about P, we can predict or calculate what will happen to P, and it was right. It would happen. But there was a problem. We were thinking that how are they entangled and how the other proton knows what is happening or what is being observed for P. So this was given by something called Bell inequalities. According to this Bell inequalities, there was some kind of information being passed between the two protons on subatomic particles such a way that we were not able to detect it, and that was a very high concern. So this year's Nobel Prize in Physics has been awarded for something solving our confusion about the quantum entanglement. So something along the lines happened. There were two quantum particles very far away at a distance A and B, and the distance was something like a light will take 1 year to reach. Okay, and what they did is they did the calculation for P at the location A and P at the location B within 6 years span, and before calculating they predicted and calculated what be based on the calculation of A what will be discovered or find at B, and that was exactly the same. Now the thing is, if light takes 1 year for to reach from one place to another in this case, then nothing can travel with faster than the speed of light. So no information could have reached the other quantum particle to tell us that an observation has been made at A. So there was no information being passed, and so we now know for sure that for the quantum particles to be entangled, they can be at very far places and they need not pass any information between each other. Now, the implication of this is many. There are many applications, but the very fascinating one is, imagine the Big Bang which happened. Now, the Big Bang is a mystery, we don't know many things about it. But if we find out a proton over here entangled with the proton of our solar system, which we are currently here, maybe in your bedroom, something like that. If they are entangled, we can find the properties, answers of here, and we can solve what happened at the Big Bang. So this is a major thing which has been solved, and so fascinating the application it might come. That's it for today. Till next time, take care.